Hi all, this presentation is about spasticity. Spasticity is a classical clinical manifestation of an apomotor neuron lesion, and it is a velocity dependent increase in muscle tone caused by the increased excitability of the muscle stretch reflex presenting as intermittent or sustained involuntary activation of the muscles. In a healthy person, stretch reflexes are mediated by excitatory connections between 1A afferent fibers from muscle spindles and alpha motor neurons innervating the same muscles from which they arise. Passive stretch of a muscle excites the muscle spindles, leading 1A fibers to discharge and send inputs to the alpha motor neurons through mainly monosynaptic but also oligosynaptic pathways. The alpha motor neurons in turn send an efferent impulse to the muscle, causing it to contract. This is the normal physiology of muscle contraction following a stretch reflex. Basically, there are two systems responsible for muscle tone. The inhibitory system, that is corticospinal tract and corticoreticular spinal tract, and the excitatory system, which consists of medial reticular spinal tract, vestibulospinal tract and dorsal reticulospinal tract. Normally, both the inhibitory system and the excitatory system are in dynamic balance, and therefore the inhibition to the spinal cord is easily adjusted according to the demand. In case of apomotor neuron lesion, there is a disturbance in the balance of supraspinal inhibitory and excitatory inputs, producing a state of net disinhibition of the spinal reflexes, leading to hypertonicity called spasticity. And this spasticity is velocity dependent as well as length dependent. Spasticity varies with speed of movement. The faster the muscle is stretched, the greater the resistance to stretch or passive elongation is felt. Stretch reflex increases and the therapist detects an increase in muscle tone. When we give a slow passive stretch to a muscle that's having a lesion in apomotor neurons, the stretch reflex tends to be small and the tone may be perceived relatively normal or just increased. Besides the dependence from velocity, spasticity is also length-dependent phenomenon. While passively stretching a muscle, more resistance is felt in the initial part of stretching, but with continued stretching, a sudden release of resistance occurs, which is described as clasp knife phenomenon. The excitation of slowly conducting higher threshold inhibitory group 3 and 4 muscle afferents may also be responsible for this phenomenon, and this is called clasp knife phenomenon. Now, talking about cerebral origin spasticity. Normal brain delivers inhibitory neural signals to the spinal cord. These signals modulate the reflex signals and the tone remains normal. Damaged brain fails to generate inhibitory signals or it sends inadequate inhibitory signals and this leads to spasticity. Now, talking about spinal origin spasticity. Normally, inhibitory neural signals sent to the alpha motor neuron that modulate reflex signals and tone remains normal. Damaged spinal cord fails to relay adequate inhibitory signals and this leads to spasticity. Whether it is of cerebral origin or spinal origin, anti-gravity muscles are predominantly affected due to spasticity. Various objective measures are available to assess spasticity. Modified Ashworth scale is one among them. The grading ranges from 0 to 4. It has 0, 1, 1 plus, 2, 3 and 4. Stay tuned for upcoming videos.